Loss of interest or motivation is often dismissed as temporary fatigue, stress, or the normal ebb and flow of life's energy. Yet, when this lack of drive becomes persistent, it can signal early cognitive stress or disruption in the brain's reward and executive circuits. The prefrontal cortex and limbic system, responsible for planning, decision-making, and regulating emotional responses, are particularly sensitive to metabolic imbalances, neurotransmitter deficits, and neuroinflammation. When these systems are compromised, even previously enjoyable activities, hobbies, or social interactions may feel burdensome or unrewarding. This early apathy is not merely an emotional nuisance. It is a red flag indicating that the brain's ability to generate motivation, process rewards, and maintain cognitive engagement is under strain. The dangers of ignoring this symptom are significant. Loss of motivation and interest often precedes more pronounced cognitive and emotional deterioration. Individuals may begin withdrawing from social engagements, neglecting responsibilities, or abandoning activities that once brought joy. This withdrawal not only diminishes the stimulation the brain receives, but also accelerates the decline of neural pathways through disuse. Chronic apathy can reduce cognitive plasticity, the brain's capacity to form new connections, while simultaneously increasing vulnerability to depression, anxiety, and executive dysfunction. Over time, the combination of disengagement, reduced stimulation, and underlying neural stress creates a feedback loop that progressively weakens mental resilience and accelerates cognitive decline. Neurobiologically, loss of motivation is closely linked to disruptions in neurotransmitter systems, particularly dopamine, serotonin, and norepinephrine. Dopamine is central to reward processing and goal-directed behavior. When its production or receptor sensitivity declines, activities that were once enjoyable lose their appeal, and initiating tasks becomes effortful. Serotonin and norepinephrine, meanwhile, modulate mood, attention, and stress resilience. Nutrient deficiencies, common in modern diets, can impair the synthesis of these neurotransmitters. For example, B vitamins, choline, and omega-3 fatty acids are essential cofactors in neurotransmitter production. Without adequate intake, the prefrontal cortex and limbic system cannot function optimally, leaving individuals vulnerable to apathy, irritability, and cognitive sluggishness. Chronic inflammation, metabolic dysfunction, and oxidative stress further exacerbate the problem. Persistent low-grade inflammation damages synapses and disrupts neuronal communication, while insulin resistance reduces the energy available to high-demand brain regions. Stress, poor sleep, and sedentary behavior amplify these effects, diminishing motivation and compounding cognitive vulnerability. Even subtle, ongoing deficits in energy metabolism or neurotransmitter balance can erode initiative, reduce curiosity, and interfere with the mental agility required for daily life. Warning signs often appear subtly at first. You may notice reluctance to participate in activities that previously provided satisfaction, procrastination on routine tasks, or an increasing preference for passive entertainment over active engagement. Social withdrawal may follow, with less frequent contact with friends, family, or colleagues. These changes are not just psychological, they reflect an underlying biological strain on the neural circuits responsible for reward, planning, and motivation. Left unaddressed, these early signals can progress to more severe cognitive and emotional deficits, including depression, memory impairment, and executive dysfunction. Preventing or reversing this trajectory requires a multi-pronged approach that addresses both neural health and lifestyle factors. Nutrition is foundational. Omega-3 fatty acids from salmon, walnuts, and flaxseed support neuronal membrane integrity and neurotransmitter function. Eggs, leafy greens, legumes, and whole grains supply choline, B vitamins, and folate, which are critical for dopamine and serotonin synthesis, enhancing motivation, focus, and mood stability. Antioxidant-rich foods such as berries, citrus fruits, and colorful vegetables counteract oxidative stress and support synaptic health. Adequate hydration is also essential, as even mild dehydration can impair energy metabolism and exacerbate feelings of apathy. Cognitive and social engagement are equally important. Activities that challenge the mind, learning a new skill, practicing a hobby, solving puzzles, or playing strategy-based games, stimulate neuroplasticity, reinforce neural pathways, and maintain executive function. Social interaction provides emotional support, feedback, and engagement with complex cognitive tasks, all of which are critical for sustaining motivation. Volunteering, group classes, or structured social activities can create opportunities for meaningful engagement while strengthening neural circuits. Physical activity amplifies these benefits. Regular aerobic exercise, resistance training, and even moderate daily movement improve cerebral blood flow, enhance energy metabolism, and stimulate the release of neurotrophic factors that support synaptic growth and connectivity. Exercise also boosts dopamine and serotonin levels naturally, providing a biochemical foundation for motivation and emotional resilience. A consistent exercise routine, even 20 to 30 minutes per day, can significantly improve mental energy, initiative, and engagement with life's challenges. Sleep and stress management are crucial adjuncts. Sleep consolidates learning and restores neurotransmitter balance, while chronic stress disrupts dopamine and serotonin pathways, exacerbating apathy and cognitive sluggishness. Mindfulness practices, meditation, yoga, and structured relaxation techniques can reduce cortisol levels, improve mood regulation, and preserve prefrontal cortex function. Ignoring persistent loss of interest or motivation can have long-term consequences. The brain thrives on stimulation and engagement. Prolonged disengagement reduces neural plasticity and accelerates cognitive decline. Social isolation, reduced activity, and diminished mental challenge create conditions that favor executive dysfunction, memory impairment, and emotional dysregulation. Early intervention, through targeted nutrition, structured cognitive and social engagement, physical activity, and proper sleep, is essential to maintain neural health, preserve motivation, and prevent the downward spiral toward more severe cognitive and emotional deficits. Ultimately, chronic apathy and loss of interest are not merely psychological issues. They are early signals of neuronal stress and reduced neurotransmitter function. Heeding these warning signs promptly and implementing consistent, supportive interventions allows the brain to rebuild motivation circuits, sustain executive function, and maintain mental agility. By nourishing the brain, engaging socially and cognitively, and protecting physical and emotional health, individuals can prevent minor motivational lapses from becoming significant cognitive decline, preserving clarity, focus, and quality of life well into the future.